Hello students. Hello students. Welcome to today's online session on rdbms. In our today's session we are going to discuss about the parallel databases. These parallel databases are designed in such a manner that we will be improving the performance of the parallel implementations. Means to say that when you want to access the data concurrently, when you want to execute the transactions concurrently, then at that particular time we could use what parallel databases. How we will be doing that, we can observe in this particular session. Okay, try to observe the definition. In a multiple cpu works in parallel. Multiple cpu means what? We are not having single cpu, we are not having single system, we are having multiple systems which are working for that particular process, and they can improve the performance through parallel implementation of various operations such as loading, building indexes, and evaluating the queries. All these operations are divided into the simple pieces so that can be distinguished among the cpus. So each and every system will be taking its part and they will be executed simultaneously. Parallelly they will be executing those particular tasks in order to complete them in the quicker time. So this will happen when we are going for the parallel database systems. Okay, as a result you people will be having the result in pieces and we will be combining them in order to have a larger application output. Okay, this can be observed in the case of parallel database systems. So it is in parallel processing, many operations are performed simultaneously, as I already told you people, and as opposite to centralized processing in which several computation is performed. See, if you are having only one single cpu and if it is performing some operations, say suppose if it is having 100 instructions, if it is taking 10 seconds in order to execute this, then what will happen is when I'm having 10 systems, that in 1 second itself we can complete these instructions. In the same way, when we are executing the instructions in a parallel manner, when we are completing the transactions in a parallel manner, so your systems can have a better performance. That is the reason we are going for this particular database systems. See the application of this parallel database also. It is usually ensures the database system can continue the performance of accepting the speeds. Okay, so even if the database is having number of transactions that has been increased, if they are performing parallelly by the different kind of cpus, even one cpu fails also other cpu take care of it. Okay, in that particular manner we will be using database systems in a parallel manner so that it can give the better performance. Cost of performance will be increased in this particular things, I can say, and we do have some advantages and disadvantages which are related to this particular topic. Just go through them. Okay, increased throughput, it can have so many inputs at a time and it can be having an increased response time. As you are having multiple system, every process will be getting the response within the time itself. Okay, and longer queries will be divided into sub queries so that they can execute them parallelly. Okay, and this can be used in large applications where you people will be having day-to-day updations and say number of transactions that has to be done parallelly. Okay, at that particular time we will be using this parallel databases, I can say, and we are having some disadvantages which are related to it. See, more startup cost. See, as we are having multiple CPUs, in order to maintain them, we will be putting so much cost towards your CPU, I can say. And interference problem. As we are connected to the interconnection, that should be made in such a manner that we should not get any problem within that particular database. And skew problem is that when we are skewing the data from the database, it should be maintained in the disk storages or else somewhere in the physical storage we will be storing the database. No, at that particular point we should skew the data from that particular thing, and at that particular time it should not provide any problem. Okay, that is the reason we will be considering these three as major problems in your parallel databases. Okay, architectures of parallel databases, you see, in this they will be categorizing these particular architectures into three types. Okay, the first one that we can discuss is multiple cpus. Okay, shared memory multiple cpus, and shared disk multiple cpus, and shared nothing multiple cpus, and we will discuss them in brief one by one. In our today's session we are going to discuss about shared memory multiple CPUs. Okay, see the picture once. Here we are having different kind of storages in layer. Okay, different kind of storages, and this storage or as the data that have been stored in the memory, that will be stored and shared among the network, shared among the interconnection network, I can say. And each and every CPU can directly access this particular data from the network without any disturbance through other CPUs. Okay, this is what the main motto, main objective of your shared memory multiple CPUs. Now we will go through the definition that we are having in your material. In a shared memory, a computer have a several multiple CPUs, as we can see in the figure. We will be having them, and related to them we will be having an interconnection in between them. Okay, so when we are having the interconnection between the computers, they can access the data globally without interfering any other CPUs. And a common disk, main memory, and the common array of storages where you people will be storing the data, as we can see in the figure. Okay, sorry, we can see in the figure there will be a shared memory and arrays of disk will be there where you people will be storing your data, and this data can be accessed by CPU without disturbing other CPUs which are working onto it. And in between that we will be using multi-threaded operating system, so that every CPU can individually work onto the data without disturbing the other part of your databases. Okay, and a DBMS will be utilized, multi-threaded DBMS within this. Okay, and see, shared memory architecture is similar to your single CPU architecture or centralized database system architecture, where you people will be having a single CPU and DBMS and then database. It is similar to that only, but here we will be having more than one CPU, which will be increasing your performance. Okay, when we are comparing with a single CPU. Okay, in this way we will be having the arrangement in case of your shared memory CPU. And the benefits when we are going for the CPU arrangements or as a shared memory multiple CPUs, it is creating a common communication between what different kind of CPUs. They are extremely efficient, they will be doing the communication by receiving and sending the messages among them itself. Okay, by receiving and sending the message among themselves, so that when they are discussing about the communication, when we are discussing about the communication will happen within the CPUs by sending and receiving the messages through network, and they are much faster using memory writes, and which usually takes less than microseconds. In order to send and receive messages, they will be taking lesser time, and communication overhead will be decreased in this case. Okay, and see, limitations of your shared memory architectures, the disadvantages you can say why we will not go for shared memory architecture are this. Okay, memory access have very high speed mechanism that is difficult portion without losing efficiency. See, it is very hard to maintain. Why? Because we are having multiple CPUs which are concurrently accessing the database. The speed in which they are accessing the data, that should be planned in such a manner that it should not reduce the efficiency. That is what it means is. And different CPUs have equal access to the common memory. Okay, every system will be accessing the data, they will be having the equal access of common memory. And also see, when we are having a shared memory, when we are having a common memory, it should be of lengthier one. See, if you are having 4 GB, it will be working differently. If you are having 16 GB RAM, then it will be working differently, right? We should have them, we should maintain them in order to maintain this particular architecture in a proper manner, I can say. Okay, since the communication bus or interconnection network is shared by the CPUs, a shared memory architecture is not scalable beyond 80 to 100 CPUs in a parallel manner. See, as we can improve the systems in your network, whenever we are improving the CPUs in the network, you people will be sharing the common shared memory through the network. See, if say suppose if 3 systems are working, then the speed will be different. If 6 systems are working, then the speed will be different. If we are working with 100 system, then the speed will be different. See, whenever we are increasing the number of CPUs in your network, then automatically your speed will be reduced. That it will become a bottleneck. Why? Because everything should be accessed from a shared memory itself. Okay, then that will become a biggest problem over here. Okay, that is the reason we are saying that these are disadvantages of your parallel database. In addition, of CPU causes CPU to spend more time waiting for their turn on the bus to access the memory. As I already told you people, if you are having multiple CPUs, number of CPUs are increased in your parallel database systems, then you need to wait for your turn in order to get the data from your data disk. Okay, so this is your shared memory multiple CPUs ma. The remaining things, shared disk multiple CPUs and shared nothing multiple CPUs, that we will discuss in our next lecture. That's it for now. I hope it is clear to you people. If there is any doubt, just let me know by your comment. Okay, that's it for now. See you in the next one. Thank you.